But anyhow, my name is Yunmi Park, and I'm from Seoul National University. And he said we are livers, but we don't think like that. Anyhow, so I put my kind of cool photo because I'm giving a lecture at the school, and this is Yunmi. And then he already introduced me, and then he introduced my career path from university student to the PhD student and then professors here. But if you want to know more about me, probably you can visit this website. My lab is called as a site planning. No, site planning is my company name. It's called as a Smart City Planning Lab, and you can find more information about me and my current projects and publications. So probably you have a chance to check your scival.com. So it's produced by Elsevier. It's a very big publishing company. And then they let you know which or what kinds of study that you are working on right now. So I'm in a department of civil and engineering, environmental engineering department. So probably you can think me as a engineer, right? But actually, the Elsevier lets us know that I am more of a social scientist. So I'm not an engineer, and I don't want to be called as an engineer as well. So anyhow, if you can see this, I'm working on social science, and then I'm doing a little bit of environmental science and a little bit of a computer science here, and then agriculture and things like that. But even though the title of my lab is Smart City Lab, but I'm doing very social kind of scientific work here. So for you, I looked at the website of this department, and then you guys are from everywhere, electricity, and then maybe transportation, and where are you from? No, not well, from the major. Yeah, I know. Based on your accent, I can tell that you're Busan, from Busan. So your major in yeah, electrical engineering and things like that. So mines are so social science scientific. So as you can see, it can be seen as kind of boring, but anyhow, I'm looking at the pandemic and the vacant land and shrinking cities or gentrification. And so most of them are about the shrinking cities. So I've done only one work about the active travel to school for children. That was it. So the reason why I'm talking about my background this long is so actually the society is evolving, right? It has progressed a little bit. So planning, I'm doing a planning, and the planning has rooted central to my research, teaching, and practice. But my tools have evolved a little bit. So my probably the topic stays there, but I try to adopt the new skills. So I'm still learning. So probably I'm more a beginner compared to you guys in terms of adopting tools or using tools, but I'm still learning. So I graduate Busan National University in 2002. So based on that, you can guess my age, right? So I'm in my 40s, so 45 years old, but still I'm learning because the society is changing, right? So before then, the major tools, before 2020, I used Stata, HLM 7.0. Have you ever used that program before? Yeah, it's a statistical package that you can do a multi-level linear regression things, right? So it's not, I mean, probably you guys are not familiar with those kind of statistical learning tools, but I use that. And mostly the data I'm using is for public data, and then such as census data and then survey data. But now I try to use a little bit of a different the tools like computer vision, machine learning, and digital twins. So even a social scientist, they try to learn some new things from other fields and then other domains. So that's what I want to say here. Oh yeah, this one is really new. That one, the beam. I learned beam this year to teach my undergraduate students. So this is the software that you can draw or you can make some kind of 3D building models or some other construction sites. So it's kind of new. So that's what I want to say. So how social scientists could use these new tools. So there are some other things as well, but we are really interested in the input sides. So we want to know the determinants of the phenomena. Why and what makes this, or what kind of drives this phenomenon or things like that. So if you can see the examples here, if you put some inputs, right? And then in other words, if you find your X variables to identify the Y, right? So Y is something that impacted by the X or determinants of something. So we want to know. So for example, we want to know the factors that influence the uh, improvement of the children or things like that. But on the other side, engineers has more interest to find out the outputs. So it's called as output-oriented the approach. So for example, so you want to know which neighborhoods has the highest crime rate, right? So you can kind of specify, oh, this area has a high crime rate, or this area has a lower crime rate. But if you're using the machine learning things to predict this phenomenon, probably you may not know the specific determinants of it. And the factors that you put in your machine learning models, so probably you cannot really explain what makes this happen, right? 그래서 다시 살짝 얘기를 하면 머신러닝에 넣는 그 팩터들을 통해서 사실은 이게 이 영향을 미치는 요소라고 말을 할 수는 없습니다. 예측을 하는데 도움을 주는 요소라고 할 수 있긴 하지만 so the social scientists are so afraid to explain the factors that are used in this output oriented approach because you may interpret the result a little bit differently, right? So for example, things like this. The black one shows the number of PhD students or who granted the PhD, the PhD or doctoral degree in the United States in the civil engineering department, right? It grows up like this, and then the red one indicates the consumption of mozzarella cheese per person in the United States. But as you can see a little bit of similar trend, right? So probably using the cheese consumption, you can predict the number of doctoral degree recipients in that year. So there's no relationship between them, but still you can predict the number precisely. So that's what we really afraid of it, right? So we want to know which was the major factors to predict the numbers of the PhD recipients in the United States. So anyhow, recently people are talking about the explainable artificial intelligence or the interpretable machine learning, things like that. So maybe you can kind of tell which factor contributed to make the model more better, things like that. But still, it's not perfect, and it's not our main concerns or research interest. So, but still, we try to use these new skills to collect the data, especially it could be kind of my personal perspective, but it provides a foundation for the rapid collection and the processing of unstructured and then big data. So for example, it can kind of complement the audits and survey. 그전에는 서베이와 현장 조사를 굉장히 많이 했습니다. 근데 요즘에는 이제 그런 것들을 대체하는 요소로서 이런 것들을 많이 쓰는 것 같습니다. So I presented two examples here. So the hedonic model, it means you can measure the neighborhood satisfaction based on the housing value, right? So you're paying more for a house in Gangnam area in Seoul, right? Why? Actually, the value of the house is exactly similar, right? It's an apartment. If it is a 100 square meters of the house units, so probably you need to pay the exactly same price because you're using the same construction materials and then labors or things like that. But you are paying what? For the neighborhood conditions, right? If it is really close to the subway, probably you want to or you are willing to pay more about it, things like that. So you can think about different factors, but uh, this random forest model can give you a foundation which factor could be selected for your analysis or things like that. So in other words, the random forest is used for data preparation instead of the predicting something or predicting the house price. So it's a little bit different. I mean, we are tweaking the process a little bit. And at the same time, so probably today I will talk more about this computer vision things. And well, you don't have to really go out and then check how many trees are there and then how buildings are look like or things like that. Instead, the uh, the computer is doing, I mean, it's working for you actually. So this is probably you will get a sleep or you can be a little bit sleepy when the lecture goes on. So I'll give you a summary of this, the work that I want to present today. So I want to check or I want to make, what can I say, a little bit of automated the survey score uh, for the uh, for the specific images that you are you are getting. So if you look at the photo and then say, oh, it looks a little bit declined, or it looks a little bit boring, or things like that, you can make it to the numbers, right? So usually when you are getting a survey, you have to pick from 1 to 5, like 5 Likert score, right? If you're really if it looks really declined, you can say 5, or it looks very new, you can select 0, right? So usually we've done those kind of things by using the survey. But in this case, we made a data set for the training and then test as well. And we make a model to predict the perceived urban decline score. So we're going to use it as a Y. So, and then we're trying to find the X. What makes things uh, to be seen more declined or less declined, things like that. And we found out the objective measure of urban decline. So objective measure means things are collected by the public data, the census data, or some other publicly released data, and our perceived data. What's the relationship between them? So we found out the objective measures partially explain the perceived urban decline. 그러니까 subjective measure로 뭐지? 저희가 서베이한 것들을 예측하는 모델을 만들었는데 그 두 개의 관계를 보니까 우리가 원래 많이 쓰는 이 objective measure라고 하는 공공에서 주는 데이터가 사람들이 생각하는 perceived data라고 하는 subjective한 것들의 한 50 몇 프로 정도는 설명한다는 거예요. 그렇다고 하면 그거 이외에 한 40% 다른 것들이 뭔가 보이기 때문에 이 사람들이 이 장소가 훨씬 더 쇠퇴했다, 쇠퇴하지 않았다 이렇게 느낀다라고 이제 뭐 생각을 하시면 될 것 같습니다. 그래서 모델을 이렇게 Y를 만들려고 만들었고 그 다음에 사실은 이걸 하기 위해서 얘는 서브로 이렇게 들어갔다고 보시면 돼요. 그래서 Y라고 하는 것을 구하기 위해서 나중에는 그냥 이 어널리시스를 하기 위해서 사실은 Y를 가져왔다고 생각하시면 될 것 같습니다. So to explain a little bit about the research background here. So we want to look at the commercial district, 상권 in Korean. And so you may have a chance to see some kind of articles from the news outlets like this. And the commercial districts are losing their vitality. Actually, the Myeongdong is reviving again after the COVID, but at the time or sometimes somewhere here in the old towns in Busan, Daejeon, and they're losing their vitality. So the government is really worried about it and the residents are really worried about it, right? So they put a lot of investment for it. 도시재생 사업, especially the urban regeneration project that the previous government kind of pushed a lot. They spent so much money to make this area to be revived, but it was not really successful though, but anyhow. So you can have a chance to read those kind of articles from the news outlets. And then if I quote a little bit here, and then you may witness the frequent closure of self-employed business started by young employed and retired baby boomers have been reported in South Korea, which is due to the excessive competition, lack of relative skills, and growth of online shopping consumption. So think about the baby boomers. So if you are fired or laid off from the company, and then they're thinking of having what? The Korean BBQ place or chicken place, right? So that's kind of their path. But they're not that successful. And also, they're losing jobs sometimes, many times. And recent severe social distancing measures during the COVID and limits on the maximum numbers of people at their gatherings and nighttime business during COVID-19 harm to small business owners as well. So as I mentioned before, actually the to revive or to make these commercial districts more successful or more livable or livable? Yeah, livable. And probably we can think about different things, but we need an evidence, right? So 뭔가를 이렇게 해야 되는 이제 evidence 같은 것들이 있어야 된다고 봅니다. But anyhow, so if you are looking at the special act of urban regeneration in Korea, so we made a special act to support those kind of urban regeneration projects. So say they're saying that they're indicating that so we can consider population, economy, and then built environment changes in 5 years, in 10 years, in 20 years, and maybe in 20 years. Then they're saying you can add more qualitative measures as well. But usually you can get some kind of data like this, the population, economy, and built environment. The qualitative measures, it's really hard to get it. So to get those things, you need to go out and then ask people about things like that. So most of the cities in South Korea, they are only using those three things and decide or evaluate whether this area is declining or not declining or growing. So you have to have some kind of data. That special act requires every cities should have those urban regeneration plan. So it means at the start of that plan, you need to measure those three things. 그래서 이 세 개가 보통 objective measure로 많이 쓰이는 거라고 보시면 될 것 같습니다. But we thought, our team thought that the identifying the perceived vitality would be very important as well. So think about 을지로. Have you ever been to 을지로? Yeah, it's very old. And then they're losing population as well. And then their economy is not thriving. They're quite stable. So if you're using those objective measures, we can diagnose those area as declining. But you can see so many people after 6 p.m. because of the vibe and then some other things, right? Sometimes people call it a retro. 레트로 맞나요? 레트로? So retro is very appealing to MG generation. So I'm not MG generation. So for me, retro is not just retro. It's just a part of my life. So it's not too attractive, but MG generation, it's a little bit of attraction, I guess. So, based on those ideas, we want to measure the perceived urban vitality, or vice versa, you can say the perceived urban decline. So we developed two research questions. Like this study wants to develop a machine learning model to predict the perceived decline score. We'll say it is called as a PDS afterward. And based on self-developed training data set that generated from the Street View image from Google and the web survey as well. So our sample size was 3,393. And then this is the first step, right? So we want to have some kind of prediction model of the PDS. And then we want to compare this PDS and the objective decline measures. So the study was done in 2 steps. So we looked at the literature review again, and then vitality. How can you find out the vitality? Vitality is more like a latent variable, so you cannot really touch it, right? But you cannot really see it. But if you can see, you can tell. 바이탈리티가 뭐지? 잘 모르겠는데 하여튼 보면 알아요. 사람이 좀 많고 북적북적하다든지 이제 이런 것들이 있겠죠? So these are the indicators that we found from the previous literature. And in terms of population, probably you want to see the pedestrian flow, right? If there is a high volume of pedestrians, so probably you can think this area is kind of vital, right? Then social media, public transportation, car data, and some kind of a settled population. So it means the population who are living there actually. And under the economy categories, so probably you can look at the sales data, store numbers, and transforming housing to commercial use. So things, especially this one. This one is really interesting. So think about the 가로수길 혹은 을지로 or somewhere. So usually the house was built for residential purposes, but they're transforming to the commercial uses. And then people are saying, oh, this is so cute, right? 주택 이렇게 바꿔서 많이 하잖아요. 성수동 같은 데 가보면 이제 그런 숫자들로도 뭐 볼 수 있다. And also the commercial building density or floor area ratio of commercial buildings. So it means if there's a kind of big buildings, probably there are huge needs about the commercial areas, right? And under the physical environment section or the categories as well, probably can look at the building function, density, diversity, and then accessibility to public transportation, average built year, land use mix, and land use intensity or greenery or things like that. And then we found out, okay, so the vitality indicators are from population, economy, and physical environment. So the the special act was quite right? Because they're using those three things like population, economy, and built environment. So probably the object using on objective measures are okay to measure the vitality of some area. I'm gonna skip this one. So our study area was Seoul, and then we looked at 1,490 commercial districts. So the first one is a main street. So it's like 종로, 명동, 강남, or things like that. And then there's a neighborhood commercial. So it means it's a commercial area surrounded by the residential area. So it's a little bit smaller compared to this main street, the commercial district. And there's a traditional market, and then there's a tourist zones. So we excluded the tourist zones because it has a little bit specific and the unique characteristics of it. So the main street looks like this, and the neighborhood commercial looks like this. As you can see, there's a little bit of retails here at the first floor, and the second floor is used as a residential as well. And then traditional markets, actually, the retails are occupied at the first and the second floor as well. And these are the research procedure. So probably you are in an engineering department or some kind of interdisciplinary department. So you may have a lot of interest in this one instead of the background or literature review. So we firstly we collected the data, and then we've done a web survey and the scoring. And then we made a model, like PDS model, the prediction model. Then we calculated the PDS by the commercial district. So actually, we kind of averaged out the perceived decline by the commercial district. And then we analyzed the correlation, association between Y and X using spatial lag model. So to give a little bit of details about it, and we made a kind of random point with 300-meter intervals on arterial collectors and the local roads in commercial districts. And then we collected the images from the Google, and then we set the FOV stands for 시야각. What is 시야각 in Korean? In English? 시야각? The degree that the people can actually see, right? So it's usually 100 degree to 120 Vision angle. Yeah, it's vision angle. So we set the vision angle 110. So if you want to collect the data from the Google image, you can set the FOV, the vision angle. But usually people are seeing things within the 110 up to 120. So we set 110 FOV. And after cleaning some data, so you can get some kind of weird data like this. Even though they're saying this is a street view, you can see a building inside view from the Google images. And then tunnels, it's not our interest, so we kind of excluded those things. So based on the images that we collected, so we've done a web survey. So we asked which one is look more decline. It's done, I mean, we circulated this survey only in South Korea, so it's written in Korean. And respondents compare two matched photos. And then you can just simply click. So for us, I mean, we are thinking at the time, so making just the 5 Likert scale, it would be a little bit hard, right? And then sometimes you're saying it looks 3 points. And then somebody say it's 2 points. If it's not too consistent, it could make a little bit of biased data. So we thought a very simple way to to make a ranking between those two photos. 그 월드컵 이상형 하는 거랑 비슷하다고 보시면 됩니다. 그래서 어디가 더 좋아요? 고르기가 힘들겠지만 어쨌든 계속 고르다 보면 순위가 1등부터 이렇게 끝등까지 나오거든요. 그래서 그렇게 만들었다고 보시면 될 것 같습니다. So actually the number of average evaluation per this street view images was 120. It's almost 120. In other words, this photo was examined at least 120 times, right? Then we kind of converted this ranking to the score using TrueScale ranking score algorithm supported by the Microsoft. So we didn't develop anything. We just borrowed things from Microsoft. And as you can see there, you may not really see, but there's a mu score. But anyhow, there's a score. The high score means the photo looks more declined. And then low score means it looks more new. Like this. The 0 to 9.18. So actually the minimum was 0, the maximum was 10. We rescaled between 0 and 10. So if you look at this is a Gangnam area. It looks like a yellowish and then the greenish or things like that. It shows a lower decline score. So we thought, okay, this is calculated right? And then if you look at the area around here, it's, I don't want to say it like this, but it's not affluent neighborhoods compared to the Gangnam area or Jamsil area. So basically, based on the map, you can kind of tell, I'm not really sure prediction is right or not, but still we can tell, okay, so prediction is okay. And also, we made the average of it. So if there is a little bit of an error in one image, it will be okay. I mean, it doesn't really affect the overall images. That was our defense, right? So anyhow, so after doing a web survey, we tried to develop some machine learning model using these different types of it. The mobile net, VGG16, and things like that, the ResNet 152. Actually, the actual size of this Google image was 640 by 360, but we tried to change the size of the image and then we padded sometimes, but actually this one gives us the best accuracy or best loss, whatever you want to say. So we check the MAE, MSE, and RMSE. But the problem is we don't really know this model is better than something because there's no specific, the previous literature or previous study who really look at this, the urban decline or perceived urban decline models. But we thought, hey, it's okay. So it's not good enough, but it's okay. We thought that's okay. So we are so generous to us. So we thought it's okay. Then this is the final one. So actually, we collected all the dependent variables from that perceived prediction model, and then we collected some kind of objective measures on top of that population, economy, and the built environment. We tried to look at the floating population density, resident population density, and sales per store, new permits per area, all building ratio, whether this is a main street commercial district, traditional market, commercial building ratio, or greenery, things like that. So we collected all the variables from the previous literature. And as you can remember, there is some kind of vitality indicator on the population economy and then built environment. So the OLS, so probably you're familiar with OLS, right? 선형회귀 분석? 아시는 거잖아요, 그죠? So we firstly try to run this OLS model to find out the correlation or association between independent variables and then the dependent variables. And then we run the spatial lag model. So actually the spatial lag model is used when you are detecting the spatial autocorrelation. So what is spatial autocorrelation? Hi?
So this place can be affected by the neighbors, by their surroundings. So the high can use the Moran-Stein index to test the whether the spatial organism is something.
Oh, yes, yes, yes. That's a great answer. So actually, think about it. The unit of analysis in your models, there should be very independent. So think about the five assumption of the OLS. So the first one would be like the variables or the data, individual data should be very independent each other. So it means you are different, and then you are different, so you don't know each other, so you cannot affect each other. That's the first assumption. But usually if you're friends with somebody, so probably your eating habits or exercising habits or studying habits, you guys kind of exchange your influence at each other, right? So the space, actually the space, think about the neighborhoods or 구 here, 동 here, some kind of deep sub-districts of the city. Even though there is a boundary on the map, you may not really know the boundaries, right? So what's the difference between Gangnam-gu and Songpa-gu? They are so close to each other. So if they are close enough in the space or on the space, or on the ground, so we are assuming that there is some kind of influence exchange between something that's are near or adjacent each other. So if you remember this map here, they are so close to each other, right? So we detected the spatial autocorrelation. In other words, there is some kind of mutual the influence between the commercial district. They are adjacent each other. So anyhow, we looked at the coefficients and the p-value. This is a t, I guess. It's not p, but anyhow, we looked at this, and then there are so many stars. So when we are seeing stars like this, we are happy, right? So we kind of find the right answers, and then we are ready to write a manuscript here. So except those, the resident population density, you can see every factors that we retrieved from the previous literature or previous past studies are significant statistically, right? So I can say resident population density, okay, it can make sense because this is a commercial district. Even though there is a neighborhood commercial, but we included the main street and also what? Traditional markets, right? So probably you may not really see many residents over there. So this factor is not really significant, but we're saying, again, it's okay. And then we can explain about it. So there's a plus and minus, but this is the standardized coefficient, so you can kind of compare the impact between the factors. So here, there's we found the minus for the population that floating population density. So you can interpret that way. So if there are so many floating population, like people who are moving around in this area, people are saying, oh, this area looks less declined, even though probably, or even though they may not see things from the photo, but they can kind of tell, or they might be some kind of indicator in the Google Street View images, because those the objective measures, they're collected from the publicly released data. So it's not, maybe it can be seen through the image, but you may not really see it. But still, they're saying the floating population density is minus, sales per store minus, new permits minus, and then greenery minus. In other words, if there are so many greenery or green things, they're saying, oh, it looks less declined. It's, do you know what I mean, right? Then commercial building ratio is the most dominant factor, followed by old building ratio. But anyhow, the old building ratio is a plus, the commercial building is a minus. So think about the Gangnam or Tehran area. So if you're going to the Gangnam, there are so many high and then tall buildings, and then you may not really feel it's declined, right? So we can, so after looking at this result, we thought, oh, it's quite explainable, right? And then if you're looking at the old building in from the images, or in the area, probably it really affects the perceived urban decline. So discussion. So we asked two questions at first, and then this is our answer for it. The first one, can perceived decline be inferred through computer vision? And we want to say yes. And then some of the reviewers say no, but we still say yes. And hopefully this AI model or refined model would apply to other cities as well. So we don't really test it yet, but I want to do it. But definitely, we found outliers, such as a highly developed or very declined areas, are difficult to predict. So we handpicked some photos to find out the predicted score and also the score from the survey, but it was okay. So usually, if data have a score like this, and somewhere in the middle, it was okay. But it's so outliers, it gives us some of the bias. So we need to think about the adding some more samples for the sample data for each ends. That's gonna be our next or future work that we want to work on. The question number two, what objective factors have the dominant effect on the perceived decline? So we already mentioned it, it's a building conditions. So probably that's kind of big thing in the images, right? That you can tell, so there's a building, the building is old, or whether a building is new or things like that. It's more a kind of visual factor. So probably somebody can say that. So without those kind of things like survey modeling and then analyzing, probably you may know already. But I'm all the time, I try to say all the time, I know, but we need an evidence. That's what the researchers are doing, right? So your mom can do the same. Your mom can say the same thing. Hey, if you look at the building conditions on the photo, you can kind of tell this area is a declined or not. That's very simple, but there's no evidence yet. So we're kind of try to give evidence for it. So the policy implications, all the time, the planners, they want to have some kind of policy implication. That's kind of big thing, even though you don't know, or you cannot really get the policy implication, but you have to make it, right? So we thought local governments that aim to revitalize or underdeveloped or declined area kind of may get some supports by using this automated investigation means without incurring much cost adopting traditional survey approach. So in other words, hey, you can use it as a supporting means, not probably the main means, right? You can do a survey, you can use the model, so you can use the at the same time, it will be better. So that's what we were saying in the discussion. So after then, kind of we tried to submit this research. Then we tried to kind of upgrade a little bit more about this model. So uh, this original image was processed through ResNet, CNN regression, and then we got the perceived decline score. But we tried to put some semantic segmented images, and also we tried to put some object detection data at the same time. So we labeled this as a K-scape. So we are making it because it was really hard to find the streetscape data that really shows the Korean streetscape. So if you are using some kind of things like this, so probably you can find a data set. It was developed in the United States or Europe, or it has different streetscapes, right? Have you ever been to Europe, America? It looks different, right? Yeah, so you may not really see the kind of buildings like this. So we made a 10 classes, and students worked on the labeling those objects, and it takes forever for them. But anyhow, if you add those things, I mean, this machine learning model gives a little improved the model, but it, it's not big, but still it's improved a little bit. So I talked to my students and saying, hey, it has a low resolution. Actually, the Google Street View images, you can get a high resolution before, but now we cannot get it. You can get a panorama images with a high resolution, but not with this one. So probably that's the problem of the resolution, the reason why the updated model doesn't produce the better prediction. So probably this is the resolution problem. So we may work on a little bit differently. So they are they are working on the object labeling of 10,000 picture from 3 schools, and it's been 6 months, but they couldn't complete yet. So I'm targeting to have a full K-scape data set by next spring or sometimes around there. Then after getting those things, I want to find out the vertical urban morphology of streetscape. So if you're from architecture or the planning, you're familiar with this kind of map, right? So based on this map, actually this map, the dark one shows you the lot or blocks, and then white one shows you the roads, right? So roads and lots or blocks, it's like an X-ray film, right? So you can kind of tell which one is which city. So it's very blurry, but I can still see this will be a Manhattan, right? Or this one will be, I have to cheat a little bit. Yeah, New York. I was right. The first one on the top to the left, the Portland, San Francisco, New York, Paris. Then the second row, Irvine in US, Rome, Tunis, and then Atlanta or things like that. So based on this ground map, ground and figure map, or you can call it whatever you want, but based on the lots or blocks or the roads pattern, so probably you can tell this area is where, right? So maybe we can kind of expand to the 3D from the 2D to 3D. That was what I want to do. So based on the K-scape data set, and we aim to make some kind of typology or clusters. So in other words, we want to find the neighborhood twins in Seoul, or maybe in Seoul and then Busan, right? So you may have some kind of twins in other cities. So that's what we want to do. So that's what we want to do. Oh, it's 50. Okay. So the epilogue will be the last one. So what we want to do. So is there anyone who's doing a social science work or social science kind of research? So probably no, right? So that's what I'm all the time. I mean, that's what I'm saying to my students all the time. So as a researcher, we need to work hard, but you need to see what others are doing. So we try to find some kind of new things that we can adopt in our field. For example, computer vision, transportation, or geography, or things some are relevant to us, right? And so that's what I want to say. I mean, probably you may not know what urban planners are doing using computer vision and the machine learning. So we are tweaking a little bit. So we don't really have an interest in predicting the right score, but still, if we can predict the right score or some things like that, probably we can utilize it to complement the traditional way of collecting data. So that's what I want to say. And these are not mine. I mean, these are from the American Planning Association. Uh, they are talking about the AI planning. So it's kind of similar here, right? Say in transportation, they are talking about AI, and then mobility, they're talking a lot about the AI, right? So AI is not everything, but it's kind of new thing, and probably you guys need to work on more compared to me and Dr. Kim or Chung or some kind of old generation, probably young generation. You have a lot of pressure to work on those kind of things. So AI may replace some kind of work that the people can do, like data analysis and the coding and then data management. So instead, you may have a capacity to develop the agenda, right? They are not let you to pick the research topic, right? So you need to pick the research topic, and then you need to find out what needs to be done first among so many information and issues, right? And then you are able to make or find the new issue that can adopt in your field. So that's the second one. And then 기획력 is going to be a planning ability. So you can get an help from the AI, but you need to make some kind, you are the person who's going to develop a strategy for it. And the last one, it's very nostalgic and then very emotional kind of thing. So everything is going to be digitalized, right? So we're talking about the digital transformation all the time, but the experience or connections, like soft skills, it cannot be supported or provided by the AI. So you need the one. I mean, you should be the one who need to develop those kind of soft skills, like communication, relationship, and then network and humanity. Is it right word? Humanity or things like that. So that should be that kind of topics that you need to think about again. 뭐 그런 거죠. 네. 그렇습니다. 네. Done. I'm done. Hey, so so
Oh,
it's too hot here.
right, on.
Thank you, Professor. About the picture you collected from the Google Map, I wonder what's the date of the pictures taken, because I found that the pictures in Google Map, not only the resolution is not good, but the date of the picture taken is several years ago. And when you try to do some city planning, I think some more updated image is needed. And I wonder the case graph you the data set you mentioned in the last, it says are the images in that more updated?
Right, right. So actually, the Google Street View images, as you said, it was taken by Google. I mean,
Yeah.
they said, but there are. If you are looking at the Google map, you can see free photos that are updated by everybody, right? But we are using just Google Street View images provided by Google. So you can kind of see the cars that has a camera on top. So they're kind of driving through and then they're taking pictures. That we are using that. But the problem is the lower resolution. So we changed the photo from Google Street View to Naver images. The Naver is kind of Korean Google or platform. So people are using the Naver map or things like that. But the problem is Naver is not providing the images anymore. They provided until 2021 or 22. So we I don't want to say illegally, but there is a way to collect the data. So we collect the data. We made a program. I mean, we consulted somebody to kind of get the neighbor map images. So it's more recent, as you said. It's more current, and it has a high resolution. But the problem is the photos from the neighbor, they don't include the people or person that much compared to the Google Street View images. So probably you need to very careful to choose the image source when you are working on something. So for example, if you're interested in the pedestrian accident or pedestrian some kind of behavior on the street, so the neighbor, the images from the street images from the neighbor, it's not good. But still, the Google Street, they don't really care about the quality of the photos or whatever, but you can see so many cars, like illegal parked cars or the people around here. So there is a trade-off. So you need to choose. But the Google Street View images, there's a mixture of old one and then the current one. But you can filter out based on the date. So if you want to get a current one, you can get a current one. So, but you have to pay for it. So you have to buy a credit for the developer, to use the developer API. But that's it.
Yeah.
최신 것도 있습니다.
Yeah,
최신
thank you.
것도 많습니다. 네, 없는 것도 있습니다.
He doesn't speak Korean. He's Chinese. There are more questions.
For other people.
No, there are no questions. We've got lots of questions, so. But I guess one. To me, vitality is a human being's activity rather than built environment. Okay, if I see a lot of people and I feel like that vitality is there, the vibrancy is there. Here, the Google Image Map or Google Street View, they tried to capture all the images when no people around because they wanted to take all the buildings and this and that. Don't you think, and also because of that, it doesn't really consider things over the time. For example, Tehran Road, heaps of commercial buildings, that means it's negative vibrancy. But during lunchtime or ending working time, a lot of people, 1,000, maybe 10,000 people coming out from the building. Then maybe people think, oh, vitality is there, right? Have you thought about that? Or more. To complement that, have you thought about taking public transit card data? Then you can probably see how many people are there over the time. Then your model may be the accuracy rate. Now it's a 0.56 might increase your model accuracy. How do you think about it?
So actually, those two questions are connected, I think, right? The first one, so maybe the imaging may not capture the people or some kind of peak pedestrian, because sometimes the photos were taken probably during the day, but it will be like 10, and then 12 will be different, and then 3 or 4 p.m. will be different. So I'm saying, so the rest of the, like 50% is not explained, right? Because we didn't really take into account like a peak population or things like that. And so that's why we want to kind of factor in the object detection as well. So if there's probably more people feel like it's more vital, even though the outlook is a little bit declining and then it looks so bad, but there are so many people, maybe they kind of influence the perception. So that's why we want to kind of develop or make a little bit of improvement in our model. And the second one, the transportation, kind of that will be a good data for an independent variable. But if I say, I mean, we're not a reviewer, so I don't have to defend myself. But and yeah, the floating population density. So they kind of calculate the people move around, but it will be different if I can make that's a kind of average the population density for a month, I think. So it doesn't really shows the peak, but that's kind of good point because the Dr. Chung here, I mean, we are working on different things. So they're looking a little bit the smaller scale, the micro scale. So it will be very kind of helpful indicator to think about. Thank you for the suggestion.
No problem. Yep.
Hello, I have a little question about the unoccupied rate of the new buildings. So when you think about it, is it
New permits per area?
Yeah, but when we build a new city, all the like commercial building is
Empty.
empty.
At first.
Yeah, I just want to ask you about, is it possible to consider that kind of thing from the computer vision? Or you consider it already?
If you have a training data set, maybe. If you have a data set, maybe. So if you can capture the image of it, you can kind of tell some kind of signs like this. Like there's if you're saying it's 임대, the 1층 is 임대, right? Or things like that. So you can kind of see the signage that is attached to the buildings. Or if there's a specific outlooks, you may tell. But at this moment, I'm not really sure. So you were saying, can you tell the building's vacant or not, right?
Yeah, because the outlook of the building is one of the factors that can tell the urban climate.
That's right.
Yeah, so that's why.
Especially the high or tall buildings is really hard to detect. So we are working on another project to detect the vacant house in Detroit. So actually Detroit is one of the big, large shrinking cities. So we made some kind of category about it. If the grass of the yard, like front yard, is not cleaned, so we are taking that as a vacant. And then if you find a broken window, we're saying that's vacant. If you can see some kind of the paint is outdated, we can say that's. So we found 5 or 6 categories, and then we made a data set as well by hand. So we looked at the old vacant land through the Google Images, and then we made some kind of criteria, and then we're thinking it's kind of good to project to observe it, but I'm not really sure about the tall buildings. So maybe there are some other things that you can see, like electricity data or water data or things like that, some other supplementary data, not from the images, I think, except the signage, like 임대 from a rent from somebody, or some other things. So you can think about it.
Any more questions? Yeah, some questions.
Thanks for your thanks. What? Yeah. Thanks for your great presentation. And I have a question on the how to measure the vitality of the city like Sejong, because that kind of city, in that kind of city, we can see rare people on the weekend, and we can see a lot of people weekday. So can you divide the vitality? No, the measure the vitality space the temporally. Yeah, that's.
So actually, I've seen some kind of project about that. They're using different sorts of the data, and then they're making. I mean, they deduct the dimensionality from a 5 indicator to 1, and then they're saying that's the vitality, right? So using something like PCA or TSNE or things like that, and they're using the aerial photo from the ground, so they can detect the night lights. The lights, the total lights during the night. So it may shows you that whether this area is actively used during the day or night, and then water, and electricity, and then car data, and then transportation data, and the sales data. Because vitality is kind of big concepts, like a happiness, right? You know, there is there, but still, it's quite hard to measure. Right, can be measured. So they want to take some kind of different variables and then make as a one index, or you can say scale, to say this is a vitality index or this is a vitality scale. So they're using different things. Like Google Images is one of them, and then aerial photo is another, and then you can think about other publicly released data as well. So 데이터를 굉장히 많이 쓰는 것 같아요. 근데 어쨌든 한창 계속 나왔던 거는 이렇게 하늘에서 보는 이미지를 가지고 이렇게 밤에 광량이 어떻게 되느냐인데, 작은 지역은 아니고 좀 더 큰 리전 같은 걸 볼 때 그런 것들을 훨씬 더 많이 보는 것 같긴 해요. 정확한 대답인지는 모르겠지만 어쨌든 그렇습니다.
Other question?
Hello, thank you for the presentation. I just wanted to check. Can you go back to the slide where you showed all the variables that impact the vitality? Yes. I just wanted to know if you have considered using all this kind of data, or you just use the Google image and the web survey data to predict your vitality.
So
And
it's a kind of connected question,
Yeah.
and then answer as well. So if I want to measure the vitality, whether this is a perceived or objective, so probably I can use all those data plus the perceived one, but I kind of separated those two. So these are the actual kind of indicator of vitality, whatever it is perceived or it's objectively measured, but my Y is a subjective measure of urban decline, like perceived ones, and then X will be those indicators. So I just want to see the association between those two. So which one affects the perceived urban decline? But I'm not really sure. This is not a causal effect, or I'm not really looking at the causal relationship. I'm just looking at the association. So at this moment, I can say, yeah, objective measure, it can be kind of a little bit reflected on the images, right? If there is if area is very vive and then vital and then livable, maybe you can kind of see it through the images. That was our kind of assumption. So maybe, yeah, as a next project, we can kind of consider to make more, vitality index using different types of variables and the sorts of variables. Yes.
thank you. Just one more question. Have you tried then to like vitality? I guess it's related to the individual's activity. So have you tried to model individual like behavior of the activity so that you can measure the vitality like with
In
that kind of
different
like
ways,
variables?
I will think about it. I will think about it. Thanks.
Other question?
Commuting, the mobility, that's kind of big factor.
So you could be the last one.
Yeah. So I agree with Professor He said. So the built environment mostly come from the distributed image. They are fixed, they're stable during
Right,
some period. And for the peoples, so they're like social dynamic features. They come from the survey, right? So these are self-reported, and it's not the real time. They cannot reflect the
Right,
time
right, right,
changes.
right.
So in the future, we probably can develop the. I know some studies they measure night vitality and
Right.
that separately. So I think in the future we can develop an index, consider more real-time data sources combined, and to measure the real-time
By hour, by month, or
set
things
those
like
things.
that.
Yeah.
So you said we? You can develop. You said we. I heard it. I heard it. We can
It's like
develop.
just a comment. Just a comment. Yeah, we can use a simulation to
See?
oh,
See?
okay, to consider the interactions between the individual behavior
Right.
to
right,
simulate
right.
the whole things. That also consider that. Yeah, it's not mostly so those built environments. This thing is not that accurately can reflect the
Right,
urban mentality.
Yes.
Yeah,
Okay.
it should be dynamic.
Thanks.
That's good comments.
Thank you.
Other question? Let's put it a day.
Yes,
Yeah.
please. It's super hot here.
Let's give it up for Yunmi today. Okay.